Hello and welcome to Vision Academy. My name is Hanmant Ladwa and in this video we are going to write a program to find the product of two compatible matrices. Now let us take an example and understand how exactly the multiplication of two matrices is possible. So let us write A is equal to, for example, I'm going to write 1, 2, 3, 4 are the element, and B is equal to, I'm going to write 2, 4, 6, 8 are the elements. Next we need to find the product. For example, P is equal to, here the first row is multiplied with the first column and then it will be added. So here, so we are going to take 1 into 2. So 1 into 2 plus 2 into 6. Similarly, we are going to multiply the first row with the second column. So 1 into 4 plus 2 into 8. Similarly, second row, first column. So 3 into 2 plus 4 into 6. Similarly, second row, second column. Here 3 into 4 plus 4 into 8. Now let us simplify this to get the product. 1 into 2 is 2 plus 2 into 6 is 12. 1 into 4 is 4 plus 2 8s are 16. 3 2s are 6 plus 6 4s are 24. 3 4s are 12 plus 4 8s are 32. Next further we'll simplify. 2 plus 12 is 14. 4 plus 16 is 20. 24 plus 6 is 30. And here 30 plus 12, that is 44. So this is the product of the two matrices. Now let us write the program. Here I'm going to write the preprocessor directives hash include, in angular brace I'm going to write iostream.h header file, and the next preprocessor directive is hash include, in angular brace I'm going to write console input output.h header file. Now let us write void main function curly open brace, and here in a declaration section we are going to declare all the variables. For example, I'm going to write int a of 5 5. So it is two-dimensional array of type integer. The first subscript always represent row and the second subscript always represent column. Now we are going to declare one more matrix of size 5 and 5, and now let us declare one more variable called p of size row size 5 and column size 5. Next we are going to write the index variables. For example, I'll write I, j, k. Next I'm going to write r1 and c1. So here it is row of the first matrix and column of the first matrix. Similarly, rows of the second matrix and c2 is the columns of the second matrix. Now we'll write clr scr function which is used to clear the screen. Now we will ask the user to enter the order of first matrix using cout statement. Cout stream insertion operator, in a double quotation mark I'm going to write enter the order of the first matrix, end the double quotation mark and put semicolon, and we are going to receive the response from the user through keyboard using cin stream extraction operator. And here I'm going to take row 1, that is row of first matrix. Next stream extraction operator column, that is c1. Similarly, I'm going to ask the user to enter the order of second matrix. Here I'm going to write enter the order of the second matrix. So end the double quotation mark, put semicolon, and then we are going to receive the response from the user through keyboard using this R2 and C2. Here I'll write R2 stream extraction operator C2 and put semicolon. So here in the question they have asked the product of two compatible matrices. Here number of rows in one matrices must be equal to the number of columns in the other one. So for that I'm going to use the condition called if, and here I'm going to check out the condition. For example, R1 is equal to C2. So that is row of the first matrix must be equal to the columns of the second matrix. If it is equal, if it is true, then so I'm going to use curly open brace that indicates this is the beginning of body of a if statement, right? So here I'm going to write will receive the elements of the first matrix. We'll write cout stream insertion operator in a double quotation mark. We will ask the user to enter the elements of the first matrix. So end the double quotation mark, otherwise you can put here backward slash n and put semicolon so that cursor will come down to the next line. Next we are going to use two for loops. For I is equal to 0, I is less than R1 and I plus plus. So similarly for j is equal to 0, j is less than C1 and then j plus plus. And now using cin statement we are going to receive each element at a time. Now I'm going to write here a of ij. Here I'll write a of I and subscript j and put semicolon. So after receiving the elements of the first matrix, now we will ask the user to enter the elements of the second matrix. So cout stream insertion operator in a double quotation mark, I'm going to write enter the elements of the second matrix. So backward slash n, end the double quotation mark and put semicolon. Again we are going to use iterative statement. For I is equal to 0, I is less than, here I'm going to write R2 I plus plus. Next for loop, for j is equal to 0, j is less than C2 and then j plus plus. And now we are going to receive the response from the user through keyboard, and now we are going to use the second matrix called B of 5 5. So here I'm going to use B of I j and put semicolon. So after receiving this, I need to perform the multiplication. So how exactly I've shown you earlier. So we are going to use the logic for that. So for that I have to again use the iterative statement. For I is equal to 0, I is less than R1 and then I plus plus. So one more for loop. For j is equal to 0, j is less than C1 and put semicolon j plus plus. And now I'm going to use curly open brace, and the body of this inner for loop I'm going to write product p of I j is equal to 0. And now I'm going to use one more for loop. For I'll use the next index k is equal to 0 and k is less than here I'm going to write C1. Okay, C1, then I'll write k plus plus. Here I'm going to write p of I j is equal to p of I j plus a of I k into b of k j and put semicolon. Now curly closing brace for this opening for loop, and then we are going to go for printing cout the resultant matrix is, and here I'm going to write backward slash n, end the double quotation mark and put semicolon. And now we'll use for loop. For I is equal to 0, I is less than here I'm going to write R1 and then I plus plus. Next curly open brace, and here I'm going to write one more for loop. For j is equal to 0, j is less than C1 and then j plus plus, and here I'm going to write cout. And now I have to write the result stored in product of ij. So here I'm going to write p of I j and put semicolon, and now I'm going to write cout endl, so that after the first row the cursor must have to come down to the next line to print the next row. So that's the reason we have written this cout endl. So next curly closing brace for this for loop. Now one more closing brace for the if condition which we had over here, right? So after closing this if statement, I have to write the else part. Here I'm going to write else. If that condition is false, then else part must get executed. Now I'm going to write cout. In a double quotation mark, I'm going to write matrices are not compatible. End the double quotation mark and put semicolon, and here you can write get ch function and curly closing brace for main function. Yes, now let us take an example, and here once we compile and run this program, it will ask the user to enter the order of first matrix. So for example, I'm going to enter the order 2 and 2. So the first 2 will be stored in R1 and the second 2 will be stored in C1 variable here, right? Next, after this, it will ask the user to enter the order of second matrix. So once again, I'm going to enter 2 and 2. The first 2 will be stored in R2 and the second 2 will be stored in C2, right? Yes, next we are going to check out this condition. If R1 is equal to C2, yes, we'll check it out. R1 is equal to C2, yes. So here 2 is equal to 2. Condition is true. Once the condition is true, then the control enters into the body of this if statement and it is going to execute all other statements. Now it is going to ask the user to enter the elements of the first matrix. So for example, whatever we have taken over here, so I'm going to take the same elements. For example, I'm going to enter 1, 2, 3 and 4. So it will be mapped in a memory something like this. So 2 rows, 2 columns whose index number is 0, 1, 0, 1. And here this is a matrix called A, right? So up to here it is over. Next we'll write enter the elements of second matrix. So now it is going to ask the user to enter the elements of the second matrix. So here I have already taken 2, 4, 6, 8. I'm going to take the same elements. So here B is equal to, it is going to take 2, 4, 6, 8. So it will be mapped in a memory as 2 rows, 2 columns, index number 0, 1 and 0, 1. Okay, next I want to have a product P is equal to, so even the product must consisting of 2 rows and 2 columns whose index number 0, 1, 0, 1. So after performing multiplication, we'll start inserting values in each of these memory blocks, right? So after entering the second matrix B, we are going to perform these for loops. And how exactly we are going to perform all of these, we are going to learn over here. So for I is equal to 0 for the first time, j is also 0. P of ij means P of 0, 0. So here you can see P of 0, 0 will be set to 0, correct, for the first time. Next, for k is equal to 0. Here it is pointing, I is pointing to 0 and next j is also pointing to 0. Similarly, here you can see we have 0 index I and then it is pointing j to, like j is pointing to 0, index number 0. Next, k is less than C1 I have written here. So that is the first column. So here it is pointing even k, right? So k is pointing to this particular location. Next, P of ij, here I'm going to write P of 0, 0 is equal to P of 0, 0 consisting of what? 0, correct? So here I'm going to write, because it is initialized to 0, I'm going to write 0. Next, A of ik, 0 plus A of I is what? 0, correct? Next, k is what for the first time? It is 0. So A of 0, 0. Next, into B of kj. Here I'm going to write into B of k is 0, j is also 0. Now, further we'll simplify 0 plus A of 0, 0. A of 0, 0 consisting of what? 1. So 1 into B of 0, 0. So B of 0, 0 consisting of what? 2. So it is going to multiply 1 into 2 plus 0. So 1 into 2 is 2, 2 plus 0 is 2. So P of 0, 0 is initialized to 2, initialized with value 2, right? Yes. So after performing this particular statement, again control transfers to this inner for loop by incrementing the value of k by 1. Now k value is 1. So what is going to happen now? P of ij, that is P of 0, 0 only, because I is 0, j is also 0. Now I'm going to write P of ij, that is P of 0, 0. Now P of 0, 0 is what? 2. So I'm going to write 2 plus a of ik. So a of I is what? I is 0. So a of I is 0. K is what? K is 1. Just now we have incremented its value. So k is 1. Okay, next into b of kj. So here I'm going to write b of k is 1, j is 0. Next, further we are going to simplify 2 plus a of 0, 1. So a of 0, 1 consisting of what? 2. So I'm going to write 2 into b of 1, 0. B of 1, 0. So that is first column. So here it is pointing to the second row, first column. So 1, 0 consisting of what? 6. So it is going to multiply 6. So 6 2s are 12. 12 plus 2, that is going to give us 14. So P of 0, 0 must have the value 14. So here you can see P of 0, 0 must have value 14. Yes. Okay. Once again, the control transfers to this inner for loop by incrementing the value of k by 0. C was 2. Now it was 1. So again, after incrementing, k value will become 2. Whether 2 is less than 2? No. Condition is false. Once the condition is false, then the value of j will get incremented. So this inner for loop will execute and it is going to increment the value of j. I is 0, j is 1 now and k is 0. Okay. Yes. Next we are going to perform this P of ij is again reset to 0 because the control has transferred to this particular inner for loop. Now I'm going to write this P of ij. So that is I is 0 and j is 1 now. Okay. So that is set to 0. So P of ij is set to 0. Correct? Yes. Now I'm going to write P of 0, 1 is equal to P of 0, 1 plus A of I is what? 0. K is what? 0. Okay. Next B of kj. Here I'm going to write into B of k is 0, j is 1. Correct? Yes. So now we are going to substitute values. So here I'll write P of 0, 1 is equal to P of 0, 1. So that is P of 0, 1. So this particular block. Here P of 0, 1 is set to what? 0 for the first time plus A of 0, 0. A of 0, 0 consisting of what? 1. 1 into. Next B of 0, 1. B of 0, 1 consisting of value 4. So I'm going to multiply this one with 4. So 4 ones are 4 plus 0 is 4. Okay. Next, after performing this, once again control transfers to this inner for loop by incrementing the value of k by 1. J was 1, I was 0 and now k is 1. Okay. Yes. Next we are going to perform this particular statement. P of I was 0, j is 1. Okay. P of 0, 1 plus a into ik. So here I'll write A of I is 0, k is 1 into B of kj into B of k is 1, j was 1. Yes. Next, here I'm going to write P of 0, 1. So now the value of P of 0, 1 is 4. So I'm going to write 4 plus A of 0, 1. A of 0, 1 consisting of what? A of 0, 1 consisting of 2. So 2 next into B of 1, 1. Here B of 1, 1 consisting value 8 is equal to 8 2s are 8 2s are 16, 16 plus 4, so that gives us 20, right? Yes, so 20 will be stored in P of 0 1. So here P of 0 1, so this particular block must have value 20, and you can compare this one with this particular product. Here you can see 14 and the next is 20, right? So similarly we'll go for again the control transfers to this inner for loop by incrementing the value of k by 1. Now k value will become 2. 2 is less than 2. No, condition fails. Once again, the control transfers to outer for loop by incrementing the value of j by 1. Now j value is 2, correct? So 2 is less than 2. No, condition fails. In that situation, the control transfers to the outer for loop by incrementing the value of I by 1. Now I value is 1, j value is 0, k value is 0. Okay, so we are going to go for writing this P of ij. So P of I is 1, j is 0 is equal to P of I is 1, correct? P, next j is 0 plus A of ik. So A of ik gives us what? A of I is 1, k is 0 into B of kj. So here I'm going to write B of k is 0, j is 0. Next, here you can see again it is resetting to P of ij as 0. Here I'm going to write P of 1 0. P of 1 0 is reset to what? 0. So we'll write 0 plus A of 1 0. Here you can see A of 1 1 0 consisting of 3. Now I'm going to write here 3, this multiplication symbol as it is. Next B of 0 0. Here you can see B of 0 0 consisting value 2. So here 3 2s are 6 plus 0 gives us 6. So once again the control transfers to inner for loop by incrementing the value of k by 1. Now k value will become 1. Earlier I was 1, okay, I was 1, j is 0, now k is 1. Yes, next we are going to perform this particular statement. P of I is 1, j is 0 is equal to P of 1 0, correct? So next plus A of I k. So I was 1, A of I was 1, and even now k is 1 plus B into B of kj. So k is 1, j is 0. Next we'll perform P of 1 0 is equal to P of 1 0. P of 1 0 is what now? 6, right? So we'll write 6 plus A of 1 1. So A of 1 1 consisting of what here? A of 1 1 consisting of value 4. Here I'm going to write 4 into B of 1 0. Here you can see B of 1 0 consisting 6. Next we'll write 6 is equal to, further simplify, 6 4s are 24. 24 plus 6 is 30, right? So 30 is to be stored in P of 1 0. So P of 1 0 must have value 30, right? Yes. So once again the control transfers to inner for loop by incrementing the value of k by 1. Now k value is 2. 2 is less than 2. No, condition fails. Then control transfers to this inner for loop by incrementing the value of j by 1. Now the j value was what? J value was 0, right? Now it is 1. I was 1, j is 1, and now k will become 0. Okay, so that is 1 1 and 0. So again it is going to reset to 0. Next we are going to perform the next operation. P of ij is what? I is 1, j is also 1. Next P of I is 1, j is 1. So plus A of ik. So here I'm going to write A of I is 1, k is 0. Next into B of kj. So k is what? K is 0 and j is 1. So further we'll simplify. So P of 1 1, for the first time it is reset to 0. So we'll write 0 plus A of 1 0. A of 1 0 consisting of what? A of 1 0 consisting 3. So here I'll write 3 into B of 0, 1. You can see here B of 0, 1 consisting 4. So 3 into 4, 12 plus 0 is 12. Okay, fine. So once again, the control transfers to this inner for loop by incrementing the value of k by 1. I was 1, j was 1, now k is also 1. Okay, next we are going to perform p of ij, that is p of 1, 1. So here I'll write p of 1, 1 is equal to, next p of 1, 1 plus a of ik. So a of I is 1, k is 1. So into b of kj. So here I'll write into b of k is 1, j is also 1. Next further we'll simplify. So p of 1, 1 is what? 12 plus a of 1, 1. A of 1, 1 you can see here it is 4, right? So here I'm going to write 4 into b of 1, 1. B of 1, 1 consisting of 8. Here I'm going to write 8. And further we are going to simplify. 4 8s are 32. 32 plus 12. Yes. So it will become 44. So here I'm going to write 44. And this one must be stored in P of 1, 1. So what is the P of 1, 1? It must have the value 44. So which is same as that of this matrix. Now let us go for executing this program. For that I will take you to my laptop screen.
Here you can see I have already written this program in Turbo C++ compiler to save your time. Let us compile this program by pressing Alt F9. Here it is showing success that indicates there is no syntax error. I'll press enter. Now let us run this program by pressing Ctrl F9. Here it is asking the user to enter the order of the first matrix. I'm going to enter 2 rows, 2 columns. And now it is asking the user to enter the order of the second matrix. Once again, I'm going to enter 2 rows and 2 columns. Now it is asking the user to enter the elements of the first matrix. I'm going to enter 1, 2, 3, and 4 and press enter. Now it is asking the user to enter the elements of the second matrix. I'm going to enter 2, 4, 6, 8 and press enter. Here it is displaying the resultant matrix is 14, 20, 30, 44. Let us execute this program once again by pressing Ctrl F9. And now it is asking the user to enter the order of the first matrix once again. I'm going to enter 2 and 2, that is 2 rows and 2 columns. Now it is asking the user to enter the order of the second matrix. For example, I'm going to enter 2 rows and 3 columns this time, and I'm going to press enter. Here it is displaying the else part of the program, that is matrices are not compatible. I hope you understood this program. If so, please write down in the comment box as understood. Thank you.